We have another power series. I want to determine the interval of convergence and radius of convergence. This is a really good and very special problem. So in this problem, I decide to use the ratio test. So for the an, we let the an be the entire series, and then the an plus 1. So we replace the n with n plus 1. And then for the factorial term, we take that as n plus 1. And then the next term is the 1 less than the previous term, so n plus 1 minus 1, you only have an n factorial left. And then the other one, I break that into two factors using the law of exponent. And then you do a ratio between the an plus 1 and the an. So this is a limit as n approaches to infinity. We have an plus 1, so that is n plus 1 times n factorial, and then 2x minus 1 raised to the n, and then 2x minus 1 raised to the first, and then divided by the an, so that is n factorial, divided by, times 2x minus 1 raised to the n. I would like to put it right here, 2x minus 1 raised to the n, and then we do a cancellation, cancel the n factorial, cancel the 2x minus 1 factorial, and then we have limit as n approaches to infinity. So first of all, we have n plus 1. So n plus 1 is always positive, right? Because where n is 1 or above, so we don't need to wrap that using an absolute value. And then the 2x plus 1, we do need an absolute value for that. And then this is the reason why I picked this problem. So do you see that as n approaches to infinity, that doesn't cancel anything? So infinity plus 1, that will be equals to infinity times 2x minus 1, that is equals to infinity. So you cannot have that less than 1, right? Infinity is totally not less than 1. So you cannot do that anymore. So what do we do in this case then? So in this case, how do you make this less than 1? So to make this less than 1, we have to choose a specific value. So the series is convergent. How do we do this? We say that the series is convergent when what? When x is equals to what? So let's say we have a 2x minus 1 equals to 0, then x must be equals to 1/2, right? So in order to make the product less than 1, so in order to make this product less than 1, do we agree that we have to make a 0? So infinity is infinity. Think about this. Infinity is there. There is no way to change that. There is no way to avoid that. To make the product less than 1, my only hope is we get a product equals to 0, right? So to get the product equals to 0, not infinity, I must make the 2x minus 1 equals to 0. So when 2x minus 1 equals to 0, then x must be equals to 1/2. So x must be equals to 1/2, and then since the n plus 1 times 2 times 1/2 minus 1 is equals to 0, and 0 is less than 1. So when that is less than 1, then we say the test is convergent. So this is by the ratio test. So the series is convergent when x is equals to 1/2. That means on the other hand, so x is the entire series is convergent only if when x is equals to 1/2. So we can draw a quick picture. So the picture is this. So the entire line represents x, and then at x equals to 1/2. So actually this is going to be a solid point. So when x is equals to 1/2, the series is convergent. So only convergence at that point, and then everything everywhere else is diverge and diverge. So we say that the series, what series? The power series is diverge when x is not equal to 1/2. So basically in this one we don't have an interval. So the interval of convergence is just x equals to 1/2. This is actually a one number only, it's not an interval. And then since there is only one number, we are not able to determine the radius. And this is the reason why I pick this problem. So sometimes you get a 0 less than 1, and sometimes you get an absolute value of x less than 1, and then you can test the two endpoints, right? But sometimes you get an infinity, and that's why I pick this problem as for discussion. All right, so that will be the end of this video. If you think I picked the best problem to help you, let me know in the comment section below. As always, a thank you would be nice. Subscribe to my channel, like the video for me please. I really want the channel to grow. Thank you really much for your help. Thank you for watching. I see you all in the next one. Signing off for now.